Okay, here's a fun little video about dilation. Dilation in terms of coordinate geometry, where we're going to be making shapes bigger and smaller. Think about it as you would if you're here at Disney World and you're walking down, I think this is Main Street, USA in Disney. If you look at the Disney castle in the background, it looks really small, but as you walk bigger, the castle, as you walk closer, the castle starts to get bigger. You're dilating the castle shape bigger, okay? Perspective also can be seen looking down a long hallway. Things at the end look much smaller. Or here, an example of one-point perspective. This shape, this square here, is getting smaller and smaller and smaller by increments until it's just a point that we can't see anymore. So this process of getting smaller and smaller and smaller by increments, we're multiplying by a scale factor. The way we apply this for coordinate geometry, we'll do smaller to bigger first. If I have this nice triangle, we'll just be our creative selves again and call this A, B, and C again, okay? Right now, coordinate A is -1, -3. And coordinate B is 3, -3. And coordinate C is 1, 2. If I want to dilate this, make this whole triangle bigger so it appears that I'm closer to it, I'm going to take each of these points and multiply both the x and the y parts by a scale factor. So I'm going to just choose my scale factor in this case to be 3. So that means I'm going to multiply -1 times 3 and -3 times 3. So my new A prime becomes -3, -9. Okay, multiply both. And B prime becomes 9, -9. And C prime becomes 3, 6. So let's just see if I can get a different color so we can really emphasize this. So my new point is -3, 1, 2, 3, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my A prime. My new B is +9, 2, 4, 6, 8, 9, -9. B prime. And my new C is 3, 6, 2, 4, 6. C prime. So I'm going to get a line and I'm going to connect the dots. And you can see that obviously the triangle is much bigger. Okay, so the rule that we use, I'll go back to blue so we can see, is take whatever you're doing with your x, y, and multiply both parts by the letter. Okay, I think we use the scale factor D, so we'll do D times whatever x is, D times whatever y is. Let's just see what it looks like if we're going bigger to smaller. So here, let's make this D, O, G. So right now D is the point 2, 4, 6, 8, 10, 1, 2, 4. So -10, -4. O is the point 3, 2, 4, 6, 8. So 3, 8. And G is the point 2, 4, 6, 8, 10. +10, -8. If I want to scale this down, as in I'm getting further away, I'm going to multiply maybe by a fraction. So I'm going to say maybe multiply by xy by, oh, let's do 1/2. That seems like it'd be simple. 1/2 x and 1/2 y. So in this case, 1/2 is my D, or sometimes we call it the magnitude, or the scale factor. So D prime is going to be half of -10 is -5, and half of 4 is -2. And O prime is going to be half of 3 is 1.5, half of 8 is 4, and G prime, half of 10 is 5, and half of negative 8 is negative 4. So again, let's get a new color. Let's see, negative 5, negative 2. So 2, 4, 5, 1, 2. Here's my new D prime. 1.5 and 4 is my new O prime, and 5, negative 4 is my new G prime. And so with my line, I can quickly grab those, and I'm off. So the way we write this with a scale factor of D is what I showed you before, D times X, D times Y. D is also sometimes called the magnitude. You might see that in places. Okay, so let's think about what changes here. Look back at this picture. Obviously, the coordinates change and the lengths change. But do the slopes or the angles change? Looks like we still have the same slope here, that these two lines are parallel, and that this angle looks to be the same as that angle. In fact, the triangles are similar triangles, so the angles should be the same. So we just said the slopes and the angles stay the same, whereas the coordinates and the lengths change. So this is the only one where the shape changes, right? All the other ones, the position changed, but the shape itself stayed the same. We'll see you in class.